Sample problem number 2. A sample of dry, coarse-grained soil of mass 500 grams was shaken through a stack of sieves, and the following results were obtained. Okay, so let's go directly to the given information. Ito yan siya ang test result. And then required according to the problem is that we have to determine the amount of coarse-grained and fine-grained soils. And then letter B, we need to determine D10 or the effective size, C sub U, the uniformity coefficient, and C sub C is the coefficient of gradation. And then interpret the results. So the solution, again, if we have a particle size analysis, it's best to do it using a tabular format of solution. Okay. So, and also, kung napansin nyo, ang difference ng problem number 1 sa problem number 2 is that yung second column natin will now be the sieve opening. Kasi the sieve number does not tell you the sieve opening. So, saan ba natin makikita yung corresponding opening ng isang sieve? So, you may download specification for Tyler Mesh. Okay, so makikita niyo yan siya doon. Or I will just siguro i-upload ko na lang dito sa Diagler yung reference for that one. So makita nyo doon sa reference standard na yung sieve number 4 has an opening na 4.75 mm. Yung sieve number 10 meron siyang opening na 2, and then yung sieve number 20, 0.85, and so on and so forth. Okay, then for column C, we just copy the given data. So pag i-total natin yan siya lahat, that would be 449.4 grams. So again, meron tayong discrepancy na 0.6 gram kasi 449.4 minus 500 grams. Ang difference is 0.6 grams, but that's okay. So we will be using the actual result or the result after the test, okay, not the 500 grams. Okay, so column number 4 or column D, we need to compute for the percent retained. So ang percent retained is equal to mass of soil retained on a sieve divided by total mass of soil collected after sieving. So 0 over 449.4, that would be 4.851. Hindi. 0 over 449.4 is 0%. Then 21.8 over 449.4 is 4.851%. And then 49.7 divided by 449.4 times 100% is 11.06. And then pag i-kompleto natin yan siya, that would be equal to 100% ang total. So ang fifth column or column letter E, percent retained cumulative is equal to sum of percent retained on coarser sieves. So 0 plus 4.851, 0 plus 0 is 0 kasi wala siyang coarser na sieve. And then for sieve number 10, 0 plus 4.851 is 4.851. For sieve number 20 is 4.851 plus 11.06 is 15.91. Then 15.91 plus 22.76 is 38.67. And so on and so forth. Para ang nasa pan is 100%. Okay? Pag hindi 100% yung pan, ibig sabihin may something wrong sa column E. Okay? Then lastly, the percent passing is computed by 100% minus percent retained cumulative. So 100% minus 0 for sieve number 4 is 100%. And then 100% minus 4.851 is 95.15. And then 100 minus 15.91 is 84.09%. So on and so forth hanggang sa pan is equal to 0%. Okay, so ang importante lang talaga to compute for the sieve analysis parameters or yung mga data na kailangan natin, yung mga effective size, mga uniformity coefficient, etc. is the opening and the percent passing. Kasi ito yung ipa-plot natin sa semi-log graph paper. Okay? So, this is the semilograph paper. Then, na-plot na natin ang percent passing versus the particle size diameter. So, ang ginamit ko dito is the Excel. I did not use the manual approach kasi medyo ano siya kanang tawag ani hassle. Okay, hassle na siya on my part. But I will try to make another video on how to use Microsoft Excel to generate a semi-logarithmic plot or the particle size distribution curve. Okay, so basically, for example, ito 100% corresponds to sieve number 4 or yung opening niya is 4.75 mm. So ito siya 4.75 mm and then 100%. Itong point naman na to is 2 mm ang particle diameter, and then ang percent passing niya is 95.15%. Itong third point is ang particle diameter niya is 0.85 mm. Then ang percent passing niya is 84.09%. So yan siya. As you can see, yung hindi lahat ng points or yung violet na color is nasa intermediate lines. Kasi yung intermediate lines natin represent an increment, 'di ba? So for example, sa first cycle ang increment natin is by 1. So ang second line natin is 2. Ito siya 3, 4, 5, 6, 7, 8, 9 and then 10. For the second cycle, ang increment natin is 0.1. So itong line na to is 0.2, then next 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. Tapos, kung mapansin nyo, ang opening natin, which is the label for the x-axis, is not actually kanang kumbaga sirado, kanang dili siya kanang increments of 0.1 or 1 mm. Siguro kanang sieve number 10 lang ang ang sure jud ta na naagid siya diri nga line, di ba? Makita gid niyo diri. So when you draw this using a pen and paper approach, it's not necessary na i-draw nyo lahat ng intermediate lines. In fact, ang kailangan lang ninyo i-draw ng mga intermediate lines is yung 4.75, yung 2.85, yung 0.425 or 0.25, 0.15, tsaka 0.075 para hindi masyadong marami ang mga vertical lines. Okay? So, to determine the effective size, so we will measure the distance of the point that crosses the curve with the 10% horizontal line. Okay? Ibig sabihin, siya yung point that correspond to the 10% passing. Tapos, babasahin natin kung ano yung particle size diameter niya na nag-intersect sa 10% na horizontal line and yung particle size distribution curve. Okay? So, pag binasa natin yan siya dyan, meron tayong estimate na more or less nasa 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08. So, in between 0.08 and 0.09 yung D10 natin. Okay, so later, I will show you kung ano yung exact value ng D10. Next, for the uniformity coefficient, kailangan natin ng 60, yung D60 or the diameter corresponding to 60% finer. So, same ang approach sa D10. Kailangan lang natin kunin yung, kunin muna natin yung D30. Okay? So, sa 30%, yan siya ang point na nag-intersect sa curve, and then basahin natin yung kanyang particle size diameter. So, we can estimate D30 to be in between 0.1 and 0.2. Okay, tapos lastly yung D60 or yung the particle size diameter corresponding to 60% finer. Yan siya. And then basahin natin yung diameter. So nasa ano siya, 0.2, 0.3, 0.4, 0.5, in between 0.4 and 0.5. Okay? So the exact values are the following. So ang D10 is 0.088, D30 0.16, and D60 is 0.41. Again, I will try to create a video on how to determine the exact values of D10, D30, and D60. In fact, meron itong tinatawag na calculator technique para makuha ang mga values na to. Okay, so ang D10 effective size is 0.088. So we have answered the first requirement. And then next, we have to determine the uniformity coefficient, and the uniformity coefficient is equal to the ratio of D60 and D10. So that's equal to 4.66. Then lastly, the coefficient of gradation is equal to D30 square over D60 times D10. So that's equal to 0.71. Pero pag gumamit kayo ng pen and paper approach, actually madali lang talaga magkuha ng D10, D30, and D60. So using a ruler, i-measure nyo lang yung, let's say, consider natin yung D60. Measure nyo lang yung distance ng point of intersection ng curve with the horizontal line corresponding to 60%. So approximately nasa 49 mm yan siya. And we already know that the distance, the offset distance from its starting line is related by the formula. Offset distance is equal to scale log of x. So if we use that information, so we have a known offset distance, we have a known scale or yung distance ng in between two major lines, which is 80 mm, tapos log of x. So x na lang ang unknown natin, then you can use your calculator to solve for x. So x is equal to 4.097. So sir, bakit 0.41 ang D60 pero ang na-solve na x is 4.097? So one should take note that kung ano yung cycle na kung asa makita ang point, dapat maupod to ang pag-count. Okay? So since naman ta sa second cycle, ang second cycle is from 0.1 to 1. So ang pag-count niya is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, etc., etc. So ibig sabihin, ang x na 4.097 na naa sa second cycle should be counted as 0.4097 and not as 4.097. Okay? So, what if we consider naman yung D10? Okay, yung D10 nasa first cycle siya. So, expect na kung ano yung mako-compute natin na x dito, dapat ang pag-count niya is nasa 0.01, 0.02, 0.03, 0.04, etc., etc. Okay, so using a pen and paper approach and measuring the distance of that point from its starting line, so that's approximately 75 mm. You don't need to be exact. Okay, wala man yung exact yun din na answer. So using that information, so 75 is equal to 80 log of x. Shift solve for x, so x is equal to 8.66. So ang pag-count niya is 0.01. So yung 8.66 is equal to 0.0866. Pero ang ginamit ko is 0.088. Okay lang yan kasi malapit lang man ang 0.088 tsaka 0.087. Okay, 0.087. Konti lang ang difference. Actually, sa particle size analysis, wala talaga tayong tinatawag na exact answer. Okay?